Hi guys, welcome to the continuation of the organic chemistry video. Today we are going to continue from where we stopped. As usual, this is the second series. We have about 370 something questions to tackle, and we are going to be doing it gradually as promised. So to avoid mistakes, I told you I will be correcting some of the answers which I know that are very wrong, but majority of the answers are correct. As well, I will be correcting some of them and giving you one or two reasons why the answers are not correct. So let's move on. Now we are actually here, I think 34, because we said the one at this side has actually cut. Even at the prototype I have, it's also the same thing. So the only way you can actually get those questions, like I said, is you look into the questions from your pack. You definitely see them. So please, you can actually use that as a method of getting answers to some of the questions I said that has cut. For instance, the one we have here. So, and if you are just joining us, you can consider subscribing to the channel, and provided you find anything interesting, you can just share with your friends that are also writing the UTME exam. So this is the way we do. And also, if you want to join our online course program, if only you are a science student, you are doing either PCB, physics, chemistry, biology, or PCM, physics, chemistry, math, you can actually try and write to our number which is available on our page, or send us mail to mostdacademy@gmail.com. So I will start because I told you I can only do this in 45 minutes or a max of 1 hour, because if it is too lengthy, I believe it will be boring. So I don't want it to be boring, so I'll make it so short. So let's see this, guys. 34 says cotton is almost pure dash. Now, cotton, for example, is under the organic chemistry, and we classify it as an example of carbohydrate. Now, in carbohydrates, the classification of carbohydrates, you have the monosaccharides, the disaccharide, and the polysaccharide. But be that as it may, we say we are only going to be focusing on the question and not too much of concept and picking the right answer. So, for example, now here, cotton is an example of polysaccharides. Cotton is a cellulose, so which is tagged as a polysaccharide. Now, polysaccharide, other examples are, I said we have mono, di, and polysaccharide. Now, there are examples like starch, because of other question, cellulose, and glycogen. So I hope it's not cutting. Admin, please be checking all those things for me. So these are major examples of polysaccharides, and cotton is classified as a pure cellulose because it is a form of what? Polysaccharide. I hope that is explicit. So that's that. And to the next question. We've done a lot of all these things, so I don't want us to be like wasting time, so we can cover a lot, at least today, maybe up to 70 questions, 80 if time permits. So I will increase the pace. Now, the next one says, which of the following types of reaction takes place between, this is I think this is C2H4, not written well. C2, I hope I'm not cutting, H4, and halogen. So C2H4 is just what you are going to focus on here. Now, C2H4 is an alkanes. In the last lesson we said alkanes are also known as olefins. They have general formula of CnH2n. So when they react with halogens, I told you it is an addition reaction. It is only the saturated compound that will undergo substitution reaction. So be that as it may, we don't need to waste our time. We can just say, okay, fine. So this guy is definitely going to be, because we have this guy and halogens. So it is definitely this addition reaction. Now on the next question, 36 says, which of the following species, or which of the following represent ethyl ethanoate? We have also talked about this in the last class, how to write ethanoate, alkanoate, which are called esters. I told you they are characterized by sweet smell. We did some example on some physical characteristics and as well some chemical reactions. Now the way to write that is, we already told you that the functional group is C-double. Now, I told you the normal thing is you start from the back. Ethyl, you write ethyl at the back on C-double. Ethyl is C2H5. That is ethyl. So that is how you first of all write the functional group C-double, then you write ethyl at the back. So then we have ethyl ethanoate. I told you how many carbon is et? 2 carbon. 1 carbon is already here. So the next carbon you are going to write should be what you have here, CH3. You can see now. So if I pronounce this the way I thought I explained to you guys in the last class, you start from the back. C2H5 is ethyl. That's an alkyl group. 2 carbons are eth, remove one hydrogen from ethane, you have ethyl. So ethyl, then ethanoate, like I said, 2 carbons will be one from the functional group, the other from what? Your methyl. So this is ethyl at the back, ethanoate from the back. So this is the way, which I told you, examiner can write this one as CO2, whatever, it's always the functional group. So you just look at what goes with that, CH3, CO2, C2H5. That is what you are looking for. We've done this. It will tell you which one of the questions there. I don't know. So I think this is the guy. Choice D. You can see typo or whatever, but it's clear, explicit that CH3, CO2, CO is CO2, then C2H5. C2H5 can be written as CH2, CH3. I hope you get that. That is absolutely correct. So the next is 37. Now, about question 37, we can say about 37, we have, let's say we have this. Now, 37 says, which of the following cannot be obtained by fractional distillation of petroleum. Now, be that as it may, we know that from fractional distillation and thermal cracking or catalytic cracking, we've talked about a lot of petroleum fractions that have been obtained during this process. Now, be careful that I told you guys, most of these petroleum fractions that are obtained by fractional distillation are the kerosene, the petrol, the asphalt, the bitumen, the diesel, and so on and so forth. So when you break down, for example, the cane, now most of them are fuels. And there is one thing your teacher will tell you in your class is that most fuels are what? Alkanes. So that's just the logic you use for JAMB. You don't need to waste your time. You just use that logic. So most fuels are alkane. So what you look here is, okay, fine. Which of the list of options here are actually what? It's not an example of what? Alkanes. Alkanes are paraffins. They have the general formula of CnH2n plus 2. So basically, I am going to look for the one that is not what? An alkane. So I have methane, yes. Butane, yes. Now, I told you about ether the other time. Ether, like when we are talking about alkoxy, we talked about alkoxy alkane. When excess ethanol is what? Dehydrated, you are going to have diethyl or dimethyl ether. You remember that in the last class. But when it is what? Alcohol, it is not in excess. When you dehydrate it, you are going to have ethene. Don't make all these simple mistakes. So going forward, we have this option is ethene, I guess. So if this is ethene, this is definitely going to be the correct answer, because you cannot produce ethene double bond when you undergo fractional distillation. So I hope you get this. These are more like what we've talked about in the first lesson. So we move to question 38. Now, ether is an example because I told you how is ether formed. Ether has a functional group of O at the middle, then you have two alkyl group combined with them. So they can be formed when you break down alkane family. When you crack, you understand, alkane family, you can have ether. Please let that sink. So please, the next question here is question 38. You can see what I'm talking about. This is more like naming again. So about naming, we've done a lot of naming ceremony, and I don't want you guys, so I can leave this slide for you to look for the longest carbon chain. Be careful to name according to what the rules, lowest locant and all those things. So let's see how we can name this. So I think I'm leaving because I have people here to attempt that. I'm waiting. What is the answer to this? Because this is a very simple one. We've done a lot of naming. What do you think will be the answer to this one? I'm waiting just 1 minute. While doing that, let me take my water, please. So it's very simple. Look at for the longest carbon chain. It is not necessary, it must be a straight chain. Yes. So that's that. I'm waiting for response. Any answer? What's the answer? I have people here. I'm waiting for the answer, and I don't want us to waste that. Please, what's the answer to that? It's so simple now. Okay, let's do it together. If we start from here, 1, 2, 3, 4. So we are going to have. I think this is methyl, not here. That's CH3, guys. So we are going to have, here we are going to have, okay. We have, okay, is there a mistake in this structure? Because I'm looking at 1, 2, 3, 4. If I redraw it, this will be, oh wow, I think there is a mistake. I think the structure has a mistake because none of this option is going to work with what I'm saying. So this methyl is not here. This methyl is attached here. It's not that. Okay, okay. If we have, I think this is the right option, but the position of the chloro, 1, 2, 3, 3 chloro and 2 methyl. So this should be the methyl. The methyl should be here. So 3 chloro, 2 methyl, 1, 2, 3, and if methyl is there. So this guy is not here. Structure problem. This is where the methyl is. So please note that. Then if you have methyl there, you start from this guy, 1, 2, 3. I'm trying to correct the error of the type. So it should be 1, 2. So we have 3 chloro, 2 methyl. Longest carbon chain is 14. So just note that it's a typo. I won't take, and that is why I told you I'll be correcting some of those stuff. Now the next question is question 39. Now about question 39, we have that right there. Now question 39 says the alkanol obtained from the production of soap is that. We talked about this also in the last class. We said production of soap is called saponification. Now note that it is just the hydrolysis. The key word, because you may need saponification, is hydrolysis of fats and oil to give glycerol. So hydrolysis of fat and oil to give what? Glycerol. And glycerol is an example of tertiary. I told you there are 3 types of alcohol: primary, secondary, and tertiary. So when you have glycerol, when you hydrolyze fat and oil, you are going to have soap and glycerol, not ordinary glycerol. To give glycerol and soap, because I'm rushing, and soap. So this process is called saponification. So process of making soap and forming what? Glycerol. And glycerol is also called propan 1, 2, 3, propan 1, 2, 3 triol. So that is where all these things are basic things. They are definitions. So when you undergo the process of hydrolysis of fat and oil, it is called saponification. And what does saponification mean? Soap and glycerol. What type of alcohol is glycerol? It is what type of alkanol? Alkanols are also called glycerol. I am wasting kind of too much of time on questions, but notwithstanding, it is still within what I want to explain. So I won't actually disturb myself because I'm actually going to still meet up by the grace of God, because I'm only to come here and solve all these questions, not to waste time. Now, let's take the next question. The flame used by weather. I talked about this in the last video. I talked about parafins, olefin, and what? Acetylene. So I told you acetylene flames are used in cutting metals. So they use them to cut metal. So look at it. Flame used in cutting weathers is what? Acetylene flame. Now look at this, very technical. There is acetylene, there is oxyacetylene. Now the correct answer is oxyacetylene flame. Yes. Why is it the correct answer? Because oxygen also bond with what? Oxygen is also what? You guys know oxygen also bond in air, like on the go combustion. In fact, when you react a substance with oxygen, you say it is what? It is called what? Combustion reaction. So oxygen plus acetylene flame is called oxyacetylene flame, which is used in cutting metal. Not the acetylene flame, but plus oxygen. So weathers use oxyacetylene flame to cut what? Different metals. So the right answer is D and not what? And not B. Be careful about that, please. The next question is, this is a simple question we talked about also. Consecutive members of alkane. Homologous series always differs by what? CH2. That is, for example, if you take one member and you take the other member, the difference between the two consecutive members is generally going to be what? CH2. So I don't think I have to waste too much of time on this as well, because it speaks for itself. So we don't need to over waste any time. Let's just move to that. So CH2, how do we know homologous series? Look at first member, CH4. The next member is C2H6. What is the difference between these two? The next member is C3H8. What's the difference between the next two? The difference between them is CH2. This CH2 different. If you add CH2 to this one, you get this one, and that is called the homologous series. No time to be explaining, but we just have to talk about them. Now, the next question is talking about some characteristics, which I talked about in the last class. So characteristics are just, how do you get answers to characteristics? This is the logic. Whenever you have questions on characteristics, you just need to be careful. In the sense that you may not know all those physical characteristics, but you will be able to know for organic compound, they may show some similar characteristics, but there is one particular distinguished characteristics in one that will definitely help you. So let's see this guy, question 42 to 44. Before that, we might try as much to clean what we have and raise this guy up a little bit so that you guys can actually see. So we are going to answer question 42. Okay, question 41, right? I've answered that. I think I've done that. I've done 41, Abi? So 42 to 44. Now look at this. We have stories. An unknown, let's go with highlighter. Maybe this. Now we have an unknown compound has a relative molecular mass of 180. It is colorless crystalline solid. It is a solid. It is soluble in water. You know, that's a characteristic, because most of alkanes are not that soluble in water. So when you hear the word soluble in water, what comes to your mind might be alkanol. I'm giving you some hint. Now, it is a solid. Well, because it's a solid, I may be thinking about is a solid. Well, let's see. And I cannot still conclude. Well, maybe it is soluble in water is giving me something. They now say S contains element CHO. Because it contains CHO, what comes to my mind is carbohydrate. Because it is only carbohydrate that has carbon, hydrogen, and oxygen in it. In fact, we are giving the ratio of 1:1. A very good example is glucose that will come to my mind. Glucose formula is written as C6H12O6. C6H12O6. It contains CH and O in the ratio of 1:2:1. I hope you understand. Little mathematics. 6:12:6. You know, 6 can go in 12 2 times and that. So that is giving me an highlight because it is so simple for me to predict. Now, let's see. The movement now says, this guy now says, look at this. Now we are having, the compound has a sweet taste. Okay, not a sweet smell. A sweet taste. It may be sugar, but I don't know. And melt on eating. Yes, you know, it shows some characteristics of sugar. Okay, in the presence of yeast, it has, I have a confirmation that this definitely is a sugar. No, definitely, because it's talking about maybe ethanol in the absence of air. I'm coming. Now, S is converted, look at this, S is converted into compound Y and a colorless gas. Now, when you convert ethanol, fermentation of ethanol, you are going to have what? Glucose, which is what we are talking about. And a particular substance, which is CO2 gas. So when under fermentation, when we ferment glucose, look at the way I'm teaching you now. You ferment glucose, you are going to have ethanol, which is what? Ethanol is an example of what? Alcohol. Glucose was the sugar. It was fermented. We have ethanol and CO2. Now that particular S is converted to a compound Y. So maybe initially S is that glucose. It was now converted to Y. And the colorless, the Y is now ethanol, and the colorless gas is now CO2. Everybody know CO2 is a colorless gas that turns lime water milky. These are simple things you need to know. Chemistry is sweet if you know it. Look at this. Compound Y, I'm not yet conclusive. Compound Y reacts with sodium metal. Now, what is compound Y? Ethanol. I said I'm guessing Y to be ethanol. Ethanol reacts with sodium metal. Ethanol plus sodium metal to produce gas Z. I'm going to react ethanol and a pop sand. What comes to my mind is pop sand and a glowing spirit. My mind, we know that pop sand is hydrogen. Hydrogen has pop sand. Hydrogen exhibits glowing spirit. Another substance that exhibits glowing spirit is oxygen. But pop sand on its own, in its own, whenever you hear pop sand, what should come to your mind? I believe you are forming notes, should be hydrogen. So now look at it. Why also react with ethanoic acid to give a sweet smelling color? Now I predicted why the other time to be ethanol. So ethanol reacts with ethanoic acid. That is esterification react. You can see that the prediction is right. To give sweet smell. What is the sweet smell? Extra acanoate. So we are able to demystify this, and I see by that the question will be kind of very simple to solve. Now the question says, what is compound W? Now we have answers to all our questions. Now where's W? W is the last one. Now sweet smell. What do I call sweet smell? Esters. So esters, let's be fast. This is it, correct? On to the next one. 43. The molecule of X. We already have X initially. That is C6H. They said it is a 1:2:1. In fact, if you don't know, look at the option that is a 1:2:1 here. And I think, look at this one is wrong because it's what? It's a trap. This is the right answer. C6H12OC. That is why I have some prototype in front of me to correct some of these things in case something is not worked out. So C6H12O6. So that this guy is not the symbol for glucose. So note that. Then the last question is 44. Now, 44 says reduction. Now, what is reduction? Removal of what? Oxygen. Oxidation is addition of oxygen and removal of hydrogen. So we have reduction with yeast. Now, what reduction of X? What is X? Explanation matters. What is X? For my explanation, this is X. Remember? Is this not X? This is X now that we picked. X was this sugar. So when you reduce sugar, addition of hydrogen is hydrogenation. As in, we are talking about, no, I'm just trying to explain the action of X, not reduction. Thank you very much. Reaction of X with yeast. Ethanol. As glucose plus yeast. That is what? Fermentation. Fermentation reaction. Thank you, my meat. They said it's reaction and not reduction. Thank you. So now, when we do that, it's what form the basis of what? It is going to give you alcohol. Which industry do you use alcohol? It's very simple. Alcohol is used in what? Brewing industry. I guess you guys are. Then the next one is naming ceremony. You want to name yourself. You want to do another birthday. So let's see how far you can do this naming ceremony. So 45 is naming ceremony. Let's see. I'm waiting for my admiral. Please try this. Double bond is ENE. This is very simple. Remember, this is C2H5. You can break it down. If you have to rearrange this, you have to redraw that guy. So I'm giving you 30 seconds. I'll take water. Whenever I want to do naming, I always take water. I started from question. Please, no lunch. I don't want. No. I started from question what? 33, and I want to reach 70. Admin, check time for me, please. I think I'm kind of fast today. I think it's good. It's because we already had it. Okay. I'm waiting, please. Your answer. What's your answer? You have to redraw this thing. B? No. You are going for B. 2-methylbutane. Let me help you redraw. Okay, I think you guys are having issues with all this one. Should I just bring add a board? Or what should I do here? Just to draw this thing. CH3C11C. So let me add the board for you guys to draw. Look at it. We have C. Wow. For you to see CH3, CH2. Okay, let's watch it. This is C2H5, which I have broken down to CH3, CH2. Then we have C, then we have CH3 on that. I just want you guys to see it. Then we have C, we have our CH3 on that. Then we have, I just want you to see, guys, double bond CH2. Double bond CH. If this thing is drawn like this, you guys definitely are going to name this thing without any stress. But because it was drawn the other way around, watch this. Because it was drawn like this, you're having issues. and you are thinking it is just this. So you can see C2H5 is ethyl, which you can break down. So I've broken it down now. Naming it in this way now, I know it's very simple for you guys. So you can easily say, okay, you start from the one that is closer to the double bond. So definitely it should be this guy. 1, 2, 3, 4. So now the answer is simple. So pick the answer 2-methyl, whatever, butyl. Is that a butyl? Yeah? Abi? Option C. 2-methyl butyl. Are you okay with that? If you have issues with it, you can watch my organic chemistry video, Introduction to Naming Ceremony and Stuff, the IUPAC. You are going to see a lot. So that's it. It is 2. On the second carbon, there is methyl, 2-methyl, then buts. Where is but? 1, 2, 3, 4. But then 1 N, because it's on the first carbon atom. I hope you get that. So that's that. I have to bring this for understanding's sake. Then the next question. The next question says, how many isomers are there in the, I think this is C3H8. I have to confirm that. Is this C3H8? C3H8Br2. Yes. Yes. C3, let's do it together. C3H8Br2. So that should be it. So C3H8Br2. So that is bromopropane. Bromopropane. So if it is that bromopropane, now we can draw the isomer, but there is also a logic I do explain to my students in classes. Now, if you try to draw it out, you are going to see that this guy is definitely going to have 4 isomers. Now, there's this logic I give to them. I think for now, for alkanes, please, it is not going to work for all. The best method is always to draw it out, but because it is JAMB and we can predict the question. That is why we don't want to waste our time. Most of your question will be for what we call alloalkane. Whenever you have alloalkane, most of the question for isomers will be between the first and the 5. As in, the carbon will not exceed number 5. I can tell you that from teaching experience and stuff like that. So if that is the case, I can actually use shortcuts to actually know the numbers of isomers. That is the logic. But normally, if we want to get the number of isomers of C3H8 ordinarily, the logic we use for the first 5 number is C, what's even 2 raised to power n minus 4, I think, plus 1. It's been a long time I've used all these things, but it works. That's one thing about me. It works. So I'll just n stands for the number of carbon atoms. Be careful. Number 1, number 2, and number 3. Normally, you said it is not possible. The first, for this guy now, there is no isomer for, what do you call it? There is no isomer for propane because it has, the first 3 has no isomer. Is that right? The first isomer starts from what? Number 4. For instance, I can show you, if this is C4H10 now, it will be 4 minus 4 is 0. Anything less than 0, 1. 1 plus 1, 2. It has 2 isomers. So basically, you can see that this guy normally has no isomer. But when it is now an what? An ally, what we call alkyl halide, bromo. Now, there's going to be isomer because you can actually have different position of Br2 if you start drawing. Let me show you the logic. We just draw the carbon. This is what we do, teachers. Not that we are wasting our time. Now, I can put, where is Br2? 1 bromo here. 1 bromo. No matter what I want to do, 1 carbon, look at another formula is 11,248. Those that are good in my class, as in they know all this shortcut formula. You can watch my concept video. 11,248 is what I use for alcohol. 1 carbon is 1 isomer. 2 carbons are 1 isomer. 3 carbons are what? 2 isomer. Because no matter the position I want to change this thing, normally this guy is going to have 2 isomer because I can bring the 2 bromo at the same time. That is 1. I can split the bromo. 1 guy is here, the other guy is here. That's 2. Even if I say I'm doing the third one, I'm putting it here and here, it is still going to be the same name. The third one is the initial one itself. As if this is number 1, the structure itself. Number 2 is the one in which I put the 2 bromo on the same at the middle. The third one is the one in which one is here, the other one is there. I hope you are getting this. That's 3. Then there is another one. That is one thing you need to know. There is another one which it's kind of, you'll be like, how did they come about? Because you can say, okay, if I put bromo here, I put another bromo here. Then I change it. I start naming from the front and I start naming from the back. I don't know if you get what I'm trying to say. Like if I start from this is 1, 2, 3. So if I start from this is 1, 2, 3. So 1, 2, 3. You can see that the name will change if I start naming from the front, and the name will change if I start naming from the back. So those are two possible names, isomers too. So I have 3 of these, 1 of the initial one. So 3 plus 1 is going to give me 4. So that is the total number. So the logic I was talking about is that whenever you see an alkyne, alloalkane, just look at the number of carbon. Alloalkane. Then what? Add 1. I am telling you that it will always work for the first 5 members alone. Try it by drawing it out. So there is 3 here plus 1 from the allo is going to be what? 4. So the answer to the question is simple, and the answer will be 4. So that's the correct answer to that question. So question 47. I think we are now very slow. I think this is simple. 47 says, which of the following separation process is most likely to yield high quality of ethanol from palm oil? What do we do for palm oil? We ferment, Abi? Fermentation. So now, which of these options goes with fermentations, guys? Now, fractionation with a dehydrant, simple distillation with a dehydrant, fractionation with a dehydrant, fractionation without a dehydrant, simple distillation. Now, how do we ferment? That's another question I love. How do we ferment? Fermentation of glucose will give us alcohol. So it can never be this. It can never be this. So now we have options of fractional distillation. What is a dehydrant? A dehydrant is what? A dehydrating agent. What will remove water? So what do you think will be the answer? Fractional distillation with a dehydrant. So where's that? Option C. Please, let's be careful about that. Let me move this guy up and check the next question. We've talked about this one before as well. Question 48, that is cracking. Cracking of petroleum fraction yield more what? Lubricant. Please note that. Yield more lubricant. Petrol, kerosene, oh wow, 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 wow. Look at me saying wow, wow, wow. So petrol, kerosene, diesel, asphalt, bitumen, and so on and so forth. I hope you are getting this because it's very important to get all this. Now, let's move to the next one. The next question is yield more. There's yield more lubricants. There's yield more engine fuels. Oh my God! Diesel. I will have screwed that. Petrol. These are the components. Kerosenes. All these are what? They are not lubricants. They are called what? They are engine fuel. Sometimes you just have to be careful about options. Even what I have here is very wrong. So please note that it is engine fuel and not what? Lubricant. So that's the right answer to that. The next one. This is what we talked about in the last class. The hybridization of carbon in ethyne. Now in ethyne alkynes, we have sp. That is the answer for alkynes. For alkanes, keep this in mind. For alkanes, it is sp2 alkanes. These are common questions. Then for the first family, the saturated compound, it is sp3 for alkane. So I don't think this one should waste your time. And we can actually prove this too, but no time should be proving all these things. So you are going to look for the one that has sp, and I think that goes with this guy. So the next one, question 50. We are getting there. For question 50, we have when kerosene. Oh, good. When kerosene fraction from petroleum. You know, when we crack petroleum, we are going to fractional distillation of petroleum, which is called cracking or whatever, will give us more engine fuels. So now the question now is a continuation of what we've talked about, which is the same thing. When kerosene fraction from petroleum is heated to high temperature, a lower boiling liquid is obtained. This process is called, we've done this many times. Do I need to waste time on that? We've done it. It's called cracking. So that's that. Another thing is this. We've done this one. I think they asked for the name of this compound is that. I told you, just count the number of carbon. This is the functional group. We did it last time. That is what? Functional group COOH is what? Ethanoic acid or arachanoic. I said ethanoic. Arachanoic acid. That's the acid. Arachanoic acid. Please, let me tell the person disturbing me with call. He should reduce his voice. We have what's this? We have COOH. Then I told you how to count. Just count the number of carbon. 1 carbon, 2 carbons, and 3 carbons. What is 3 carbon? Pro. So that is propanoic acid. So the functional group is the only thing you need to know. Carboxylic acid, then that is propanoic acid. So don't waste time on simple question. I think the last question for this page, before we move to the next one, is hydrolysis of what? Fat and oil. What do I tell you it gives? Saponification. It gives what? Soap and glycerol. So you can see the way I'm picking them now, because we've discussed about most of them. So I think that is all for this page. We are going to go into the next slide. About the next slide, I think it continues from here. So now here we have again for the continuation of the question. So the continuation of the question is like this. Now this one is also saying which of the following is represent carboxylic acid. Now carboxylic acid is what? Arachidonic acid. We just did that now. C double bond OH. Have it? C double bond OH. You can see that. That's choice A. The next one says which of the following statement is not correct? Incorrect. Thank God this guy is not cutting this time around. Don't be tired. Hope I've used more than the 30-minute mark. Okay, I just want it to be 45 minutes as usual. Now, which of the following statement is incorrect? Now, fractional distillation of crude oil will give following hydrocarbons in order of their increasing boiling point. Now, let me tell you something about boiling point increase. Always keep it in mind that the number of carbon atom also dictates the boiling point. For example, if you have C2H6 and C4H10, definitely this guy we have high boiling point than the other one. They say boiling point is inversely proportional to the relative molecular mass. You understand? So that is the logic we use. So I take that again. The boiling point is inversely proportional to the relative molecular. That is, substance with high relative molecular mass will yield the what? With low molecular mass, we have the highest boiling point. So it's just about you looking for incorrect statement here. That should be correct. Now the next one says this guy will serve. This is double bond. This is 18. We serve as a monomer in polythene. I talked about that when we talk about different type of polymerization. I give you a lot. Isoprene, neoprene, terylene, and so on, and rubber, and so on and so forth. So I told you 18 is a monomer for what? Polythene. So when 18 is polymerized, please tell that guy is shouting now. Can't you hear me? Is he outside? Okay, please. We have this. The next one should be correct statement as well. Now let's see. I should stand like this. Hope I'm not cutting, please. So now the next one should be both one in and both one I decolorized bromine water. I think that's the correct statement because I told you if you want to test for unsaturation, you can use what? Bromine water. You can use KMNO4. You can use K2Cr2O7. Now, option D says both 2-in will react with chlorine to form 2,3-dichlorobutane. Both 2-in react with. Now, let's do that. Now, we know addition reaction is common to what? What do you call them? The unsaturated compound. Now, when chlorine is combined with butane, if it is butane, we have 1,2-dichloromethane. But when you have both 2-in, it should be what? Now, listen, the position is, there's what we call Markov-Nikov. Maybe I should quickly teach you Markov-Nikov rule. Now, when both 2-in react with chlorine, it is not going to yield 2,3-dichloro. Please note that. So please, no, it's not 2,3. That statement is wrong. But let's check the last one. Calcium carbide will react with water to form. That is the way we produce ethyne. CaC2 combined with cold water, remove impurities. You are going to have C2H2. So that is the way we do it. C2H2 plus CaO. I don't need that. So you can see that's ethyne. So all other statements are correct. This statement here is very wrong. Please note that. So, and about this one, I told you, how do you know the one that has the highest boiling point? Go by the one with what? Relative molecular mass, RMM, is inversely proportional to the boiling point. Sorry, I'm rushing now. Question 55. I'm stopping at the 45 minutes mark, so I have less than 10 minutes more. Yeah, 5 minutes more, you can see. So I have to get to 60. Which of the following formula is not isomeric to order? Which of the following formula is not isomeric? So isomers now. Oh, to stand like this is always difficult. Now, well, anyway, we are going to do it. Let me move up. Now, isomers. How am I going to know the answer? I will just focus on the functional group. Now, look at this one. The functional group is OH. What is OH? Acano, which is also called alcohol. Then, look at this one. COC. Now, O, I told you is what? Alkoxy. Now alkanol and alkoxy are functional isomers. If you don't know, you can write it down. Alkanol and alkoxy are functional isomers. I will still teach you that in the next class. I want to read 60 questions. Now, the next one says, look at this, still alkanol, and this one is not alkoxy. This is esters. This is COC. No, this is not ester. Ester is COO. This is also alkoxy, COC. Just like this, it's just kind of change. That is option. I think the question is not isomeric with order. I don't understand what they mean. I think it should be like 1 and 2, this and this, this and this. I don't know if you guys are getting what I'm trying to say. There should be two options in one. The functional isomer of this one, or basically I will check the one that is not okay, because I'm not getting this question in the sense that it should be like, for example, which of the following is not an isomer of each other? Let me just say it by mouth. Alkanol and alkanoate. Alkanol and propanol. Alkanol, I will be able to. All I know is that alkanol is going to form. It's going to have what we call functional isomer with what we call alkoxy, which is called ethyl. It's correct. Now, this is also alkanol. Alkanol can also, but if I'm counting the number of carbon, I have 1, 2, 3, 4. 1, 2, 3, 4. All of them here are alkanol. Then what I'm having here are, this is 1, 2, 3, 4. How many hydrogen? I think that's what they want you to do, but this is rubbish question. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogen, 1 oxygen. So count 1, 2, 3, 4, 5, 6, 7, 8, 9. You can see that this is correct. But that's why I say A and B are functional isomer to each other. Just count the number of carbon atoms and the number of hydrogen if they are the same. Now look at this one. How many carbon? 4 carbons. How many hydrogen? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1. It's also correct with that one. Do you understand? I'm counting. The one that is outside will be this guy, but I just want you guys to see. Count this one. 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. This is what? Wrong. So that's the answer. Because every one of them here has 4 carbons, 10 hydrogen, and 1 oxygen. Except that this one will also have that. Well, it should have been in pair. You understand? To make sense. But that's the way JAMB wants you to see that. I'm not going to waste time. I have less than. I want to stop at question 60. Then let's move. Alkanes are dash. Not all alkanes are gases. Please note that. So we can't pick that as the correct answer. The next one says, have general formula of CnH2nO. This is wrong. There is not O at the back of the general formula of alkane. Contain carbon and hydrogen is correct because all hydrocarbons contain carbon and hydrogen are usually soluble in water. Most alkanes are insoluble in water. They are usually active compounds. Some of them do not even undergo reaction because of the presence of the pi bond. I'm not going into that now. I tell you, I'm not only picking an answer. The answer to that one is what? Alkanes are hydrocarbons. They will definitely have carbon and hydrogen. Now, look at the next guy. The next guy is if an excess of a liquid hydrocarbon is poured into a jar of chlorine, excess liquid hydrocarbon, you just need to think of an hydrocarbon that is liquid in nature. It's poured into what? Chlorine. And the C jar is exposed for several hours to bright sunlight. This is substitution reaction. So simple. Then all the chlorine gas is consumed. The hydrocarbon is said to undergo, that is what we call substitution reaction of alkane family. Because when you expose what? That is, you are doing a kind of substitution reaction between halogens and what? Alkanes. So liquid alkane plus bright sunlight, all the chlorine is absorbed. Then the reaction is called what? A substitution reaction. Please note that. The next one is saying the functional, I've used up to 45. Okay, right on it. The function of H2SO4 in esterification. You know, we thought esterification is the reaction between alkanol and alkanoid to give esters. So H2SO4 is always present to serve as not a dehydrating agent. It is when you are actually preparing a tin from ethanol. Because most of you go for dehydrating agent, you are wrong. Please note that. This is the work of that guy. It enhances the reaction itself. Not, in fact, most of your distinct will pick serve as solvent. It's not dissolving anything, my dear. It is what? A catalyst, because it enhances the rate of the reaction between alkanol functional group plus alkanoic acid to give you what? Alkanoate plus water. You remember that reaction? I've written that before. So this is alkanoate, which is also called ester. Right now you should know alkanol has functional group of OH, alkanoic acid has COH, esters has COO. So these things are things you need to keep at the back of your mind. Question 59, last but one, penultimate question. Now for the penultimate question, again, I give it to you guys to name, but it's very simple to name this one. This one is a straight something. This is true metibutane. I hope you can see that. I don't think this one should waste your time. 1, 2, 3, 4. Then we have 2 methylbutane. And the last but not the least for today. And the next class, I'm going to continue. And I still have a long way to go. This 45 minutes thing is not it. We have to take it the way it is. So guys, last question says complete hydrogenation of ethyl. I told you in the last class. You understand? Unsaturated hydrocarbon are alkanes, the one with double bonds, and alkynes, the one with triple bonds. Both of them undergo addition. They cannot undergo substitution. It's only the alkane, the first one, that undergo substitution. So, but when you add hydrogen to them, they are unsaturated before. They will now give you what? Saturated. So if ethyne is a family, you are adding hydrogen to it, it will give you the saturated form, which is ethane. The reaction is in two phases. You know, ethyne, YNE, number 3. It will now give you ENE. Number 2, then ANE, number 1, because it must be saturated. That's why the question says complete hydrogenation. So from ethyne, it will give you what? Ethane. So please always keep that in mind. And this is the answer for that. So next class, by the grace of God, we should be able to take 61 to 100. Then this thing is about more than 350 questions, like I said, and we need to answer all of them. To be rest assured that when we see any question on the organic chemistry part, we would be able to do them and get them correctly. So guys, I'll see you soon in my future video. Don't forget to subscribe to this channel and click the notification button. Please do comment and let us know your opinion about what we are doing. It's highly welcome, and let your friend know about this channel. Let me say bye for now. Love you guys all. Thank you very much.